Alright, hello my wonderful students. This is part 3 of foldable number 1. For this one here, it says identify each function or situation as an example of an exponential growth or decay. And then we have to figure out if it is a growth or decay and figure out what the y-intercept is. Well, we're going to be using the I did in red here. We're going to be using the formula for the y is equal to ab to the x. So you can see we have our a here, our b here, and then our x here, and then y is y. So for this one, we're really going to be looking at our b. It's going to be the main thing to figure out if it's going to be an exponential growth or an exponential decay. So for this one here, it's the 0.95, and for this one here, it's the 2. So according to our definition, which is basically, it's since 0 is less than b, which is less than 1, because 0.95 is between 0 and 1. The function represents exponential decay. Okay, and then now we need to find the y-intercept. So the y-intercept is basically based off of, so I'll just write out the y-intercept is basically 0 and then whatever a is. Remember, if we look at here, a, b, x, this a here, so this 12, so our y-intercept is actually going to be equal to 0, 12. And the reason is because that in order to find the y-intercept, we have to submit a substitute in a 0 for x. And any number to the 0 power is always going to be 1. So 1 times the number that's right here is going to be the number that's right here. It's going to be our a. So for this one, it's 12. So that's going to be it. All right. So the next one over here. So we have y is equal to 0.25 times 2 to the x power. Remember this one? It's basically based on our b to see if we're going to have a exponential growth or decay. But this one's going to be a little different. This one is since b is greater than 1, comma, the function represents since exponential growth. And which kind of makes sense, right? Because this one here, when you square it, it actually gets smaller because of the decimal. This would be 4 places. This one doesn't. If I were to go to the first power 2, to the second power 4, to the third power 8, then 16 and 32, it just keeps getting bigger and bigger, bigger, which shows the exponential growth. And the y-intercept is pretty much the same. It's still based off the y-intercept is still based off the 0, a, because if I were to sit 0 here, this is still going to be a number to the 0 power, which still represents 1. So the y-intercept here is going to be our 0, and then 0.25 is going to be our y-intercept for this one here.